Okay, today's lesson is 3-7, solving systems of equations using Cramer's Rule. So what's important about this lesson, y'all, is the process. And as I think of us in this virtual setting, I want you to know that when I give you your quiz on this, that I will be testing different steps of the process. So when you do your homework problems, make sure that you write down all the steps and you know where everything's coming from. There are a lot of examples on here, and I don't show all the steps on every examples, but there are problems that you can practice with and know what the answers are, so you can make sure that you know how to do it. And again, if you have any questions, feel free to email me or arrange a Google Meet before you take your quiz. Okay, so Cramer's Rule. First off, we got to talk about something called determinants. Every square matrix, square is the operative word there, has a determinant. And the determinant of a 2x2 matrix is called a second order determinant. Okay. The key, as I just said, or what's important about that is it has to be a square matrix. Okay. The other thing that I want to point out to you is that it's just a number. Okay. So to start off with, of our second order determinant that we're going to talk about. Okay. If you have a matrix, okay, 2x2 in this particular case, you can write the determinant either with the letters DET in front of the normal brackets that you use with a determinant, or sometimes it is written with just looks like an absolute value sign. Okay, 2 vertical lines on either side of all of your elements. Okay, what's important is how to define that. Okay, so a determinant is a number assigned to any square matrix. And this particular one is A times D minus B times C. Okay, now I'm going to tell you this because this is what my students like to refer to this as. Actually, I'm going to go here with this one. Okay, they'll do this little, I actually do that a lot. That is symboled by downhill. It's the downhill products minus the uphill products. And we've talked about this already in some of our formulas that we had. I did have one year set of students remember this as duh. It was just an easy way for them to remember what they were supposed to do. So in this particular example, it is 24 minus, or 4 times 6, minus 5 times negative 3. And I encourage you, if you don't write this step, when you write the next one, which would be 24 minus, and I would always encourage, I don't like the way that connected, sorry. This does this sometimes to me. Minus negative 15. I would not ever change that to plus, because as I've mentioned to you before, we're going to have lots of multi-step problems, and you got to remember when you're supposed to subtract and when you're supposed to add. So whenever you're finding the determinant, you're always going to subtract on a 2x2. Downhill minus uphill, 24 minus negative 15, of course, is 39. So here are 2 more examples. We have the straight lines, vertical lines showing us that we are to evaluate that determinant. Okay, my downhill product is 8 times negative 6 minus my uphill product, which is 10 times negative 7. Now, as I mentioned to you, when you show your work in your homework, if you just want to write that step, negative 48 minus negative 70, I'm fine with that. You must write either one of those. I really prefer this one, but you can write either one. And of course, negative 8 minus negative 70 is 22. Okay, on to the next side. Downhill, negative 28. Uphill, 45. I'm going to subtract those 2. And what am I going to get? Negative 73. Okay, so then we have a 3x3 matrix, which of course is a third order determinant. And there is more than one way to evaluate the determinants. Okay, this year we're going to learn the diagonal rule. Okay, so we're going to use the diagonals. Next year, when you get into pre-cal, you will be learning a process called expansion by minors. So keep in mind, in case I didn't say it, this rule here only applies for second order determinants, 2x2s. This is only going to apply for 3x3s. And this is our process, okay? First off, you're going to rewrite the first 2 columns, which is what I've done right here. Oh, you can't see that. Poop. Okay, here's my matrix that I'm supposed to find the determinant of, and I rewrote the first two columns right there. Okay, then I'm drawing diagonals. Now, if you have a pencil, you don't have to use a highlighter. I used a highlighter. Some people like to put dashes in between the numbers, or they underline the numbers. I would not draw through the numbers with a pencil because you're not going to be able to see, and you're going to mess up the minus signs. Okay, you draw diagonals. It tells you to begin with the upper left hand, just like when you're doing a 2 by 2, and you multiply the elements in each diagonal. Repeat the process beginning with the upper right hand element. Okay, so that means if I start with the left hand and go down, that's my green diagonal, and I'm starting with -5. So when I multiply those in that diagonal, I'm going to get 10. And then what I do is I'm going to find the sum of those products. So it's going to be 10 plus the next diagonal is 9 times 5 times -4. So that's going to be minus 180. I really should write plus -180 after all that. And then the last one is going to be plus -48. My uphill products are -4, -1, and 4, which is 16. 6, 5, -5, which is -150. 2, -2, and 9, which is -36. So I am doing downhill minus uphill. And so you're going to find the sum of each of those, and then I'm going to subtract the second sum from the first sum. So downhill minus uphill is the same thing we did on a 2 by 2. Okay, so downhill means add up all those numbers in the green. That's -218. Minus, add up the numbers in blue, -170. And when you do that, you get an answer of -48. Okay, so next one, downhill, first downhill. So this could be something I might ask you for. What's the first downhill product? Well, you would tell me that that is, I wrote it down here, 40. What's the next downhill product? 96. And the last downhill product, we learned to love zeros. Okay, minus uphill. So the first uphill product is -60. Second uphill product, 256. Third uphill product is 0. Okay, downhill minus uphill gives me an answer of -60. Okay, pause if you need to, check the math, but make sure you understand that. But I think that's how I'm going to ask you some questions like that. So you need to understand what I'm asking you in the quiz when I do that. Okay. This is yet another formula for the area of a triangle. I want you to be aware of it and see it. We have done it before where all you did was take this row and write it on the bottom. Okay, but this is another method that is showed. So I want to showed is not a word. Well, in this context here. Okay, sorry, I digress. So it is 1/2 the product of the diagonals, the evaluation of that determinant. Okay, actually it's 1/2. This is key right here, y'all. It is 1/2 the absolute value of A, because the area of a triangle can never ever be negative. Okay, so I've got my 1/2, and these points, -4, 3, 3, 1, and -2, -2. The order that you put those down does not matter. The last column is ones. Okay, and when I do my downhill minus my uphill, I'm going to get 1/2, and that inside, that determinant of this 3 by 3 is -31, and 1/2 of -31, the absolute value of -31 is, of course, 15.5. So I'm showing you these problems so that you can practice with them and make sure that you know how to do them, because I don't want this to be too long for you. Okay, so the next one I have, to raise money for the rowing club, Hannah, Christina, and Dario are advertising a car wash at 3 different street corners in a neighborhood. On a map, the coordinates for the corners are 315, 64, 11, 9, and each unit represents 0.5 kilometers. What is the area of the neighborhood in which they are advertising? So it is the area of a triangle, and I'm going to use the formula that was presented in this lesson. So the area equals 1/2. These are my points, okay? 315, 6, 4, 11, 9. Fill in the last column with ones. And that's going to be 1/2 of that determinant, which is 70. So I should have told you to pause and go practice find that determinant if you need to. 1/2 of 70 is 35 square units. They asked us, what is the area of the neighborhood? And each of these is representing, it's a unit. Oh, each unit, here it is right here. I knew it was somewhere in there. Each unit represents 0.5 kilometers. So this 35 right here is 35 square units is only units. I need to change that to kilometers. So if I carry down my 35 square units, 1 unit is 0.5 kilometers. Well, that only takes care of 1 unit, so I have to write that again. And when you multiply that out, you're going to get 8.75 square kilometers. Okay, so what is important about Cramer's rule is the application that we have of that. Okay, Cramer's rule, and that's kind of the, a main application of determinants. That's what I was trying to say. It's a method for solving systems of equations using determinants. You have something called the coefficient matrix, which is a matrix that contains the coefficients of the system. Then you're going to have variable matrix, and it is several different matrices, each one formed by replacing the coefficients of the variable with the constants of the system. So that's the verbal definition. Here it is with a system of equations. So I gave you all abstract except for these are all with x, these are all with y, and these are all with z. So those are my coefficients of x, coefficients of y, coefficients of z. These, of course, are called my constants. Okay? Now, when you have a system like that, Cramer's rule tells you that x is equal to the determinant of x over the determinant of the coefficients. Y is equal to the determinant of y over the determinant of the coefficients. And z is equal to the determinant of z over the determinant of the coefficients. Okay? Now, as I just said up there, verbally, the determinant of your coefficients, well, you know what the coefficients are. You have first column, x coefficients, second column, y coefficients, third column, z coefficients. We use our vertical lines to represent the determinant. I was just making sure you could see that those are the different x, y, and z. Those are the different coefficients of each. Now, the key is to form the determinant of x. I'm going to take the constants and replace, if it's x, I'm going to replace the x coefficients. So instead of having a, f, and j, I'm going to have m, n, and p. The y and the z coefficients stay the same. Then when I go to the determinant of y, the x coefficients stay the same and the z coefficients stay the same, but the y coefficients are now replaced by the constants. And then the z, of course, x stays the same, y stays the same, and z is replaced with the constants. So just knowing that, and I hope you can see that this is a very simple way of explaining this process, but this is something that can be carried out by computers and to make our life a lot easier. It is most useful in a 3x3 if you only need to find one variable. Okay, not so easy to do if you're using one of the other methods. Okay, so I'm going to go and do an example of a 2x2, 2 examples, show you 2 of them, just to get it in your brain, and then show you a 3x3 and then let you go, because you just need to practice these. The best way to get better with matrices is to practice. Okay, so I have a system. 7x plus 3y equals 37. Negative 5x minus 7y equals negative 41. Keep in mind, and this might not be the case, however you wish to think about it. Again, this is a process that you're supposed to be learning. So it's not the time to do it a different way. You have to do it with Cramer's rule, and that's what I'll be asking you on the quiz. Okay? You are welcome to solve it by elimination or substitution or by graphing or some other method to see if you got it right. But to get full credit on the quiz, you have to show me Cramer's rule. Okay, so we have x, and x is, we'll start with the bottom. That's the determinant of my coefficients. 7, negative 5, 3, negative 7. Okay? And on top, remember, my x coefficients, which are these, are going to be replaced by my constants. So it's going to look like that. And when I do the y, where's my y? A little bit closer up. There's my y. Okay, again, the bottom is the same, and now my 37 and negative 41 are going to be in the column where the y coefficients were. So you've got the same bottom number. That does make it pretty easy, but I went ahead and calculated it. You can practice that downhill minus uphill product. X equals 4, y equals negative 3. It is a system of equations, and how do we answer a system of equations? Always with an ordered pair, okay? But in each of these, okay, downhill minus uphill is negative 136. Negative 49 minus negative 15 is negative 34, okay? Downhill minus uphill, that's what you got to remember. So here is another one, 8x minus 5y equals 70, 9x plus 7y equals 3, okay? That is the determinant of my coefficient, so that's my x. And on top, 70, I don't know what happened there. 73 is replacing the x coefficients, okay? And my y, again, the bottom is the same, and the top, the 73, replaces my y coefficients. So to continue, downhill minus uphill on the top and the bottom gives me x equal to 5 and y equal to 6. So my final answer is 5 comma negative 6. So that's a 2 by 2. I'm just going to show you some examples of 3 by 3s with, again, gives you some examples to practice. It would be a really good idea for you to pause, set it up, and see if you can do it correctly. I will show you. This is not the time. Yes, the calculator will do it all for you, but again, you got to know how to do this by hand. So my x coefficients on the bottom, those are the coefficients. 3, negative 4, 5 are the coefficients of my x. 5, 3, 4, coefficients of my y. 2, negative 5, negative 7, coefficients of my z. On the top, negative 7, negative 19, and negative 15 are going to be the first column. Okay? What does that equal? Negative 330 on the bottom, negative 345 on the top, which becomes 23 over 22. Now, I don't know about y'all, but if you had to solve this system by substitution or elimination and you got an answer like that, I think you'd be a little scared off and think you'd done something wrong. So there's good applications for it. Okay, here's my y, and the bottom is the same. So I wrote it in the same color this time, make it a little bit easier to see. So my bottom is negative 330, and my top is 855, giving me negative 57 over 22. And then my z, again, bottom is the same. Top, my constants become the last column, and I get an answer of 31 over 22. And how do I write that answer? Okay. If I ask you to solve the system, then you would give me this ordered triple with parentheses. You will not get full credit if you do not give me the parentheses. Okay. However, I still haven't decided yet. But if I'm only asking for one variable, then you don't need to put it in parentheses, and you don't need to do the whole problem. So please pay attention to the directions. Okay, last example, I'm just going to write it out so you can see it, because again, practice helps you get the answers correct. Okay, a bottom is the determinant of my coefficients. The top, I replace the first column with the constants. Okay, and that one is some big numbers, which gives you x equal to negative 4. Y, the bottom is the same. The y coefficients, my middle column is different. Okay, and z, again, bottom is the same. The last column on the top is different, replaced with my constants, and I get an answer of negative 1. So my answer to this problem is negative 4, positive 5, and 1. And that was a lot of math to do quickly. So you just need to practice. It's just computation. I think the rule is pretty basic. But again, if you have any questions, please email me or arrange a Google Meet. Thank you so much. Thank you so much. And y'all have a great day.